Hello dear students, welcome back to physics online session. So we were discussing about limitations of Ohm's law. So in case of that limitations of Ohm's law, we got that Ohm's law is not a fundamental law. So, or in other sense I can say it is not a universal law. So better you can recorrect it. So just we can consider that Ohm's law is not a universal law, and Ohm's law is applicable for only ohmic devices and it is not applicable for non-ohmic devices like semiconductor, transistors and amplifiers. So in today's session, so let me focus about that some neat questions related to current and resistance here. So just I will brush up the formulas as we already discussed in previous sessions here. So we know that basically current I is equal to what? So rate of flow of charges here. So I is equal to Q by T. So from the quantization of charge, I can write with that Q is equal to what? N into E here. So N into E divided by T we can write it. So one more form I can consider here. So for example, if that a charge particles or electron is revolving around the nucleus here. So if that electron is revolving around the nucleus, means it is about that circular motion here. So Q into, so 1 by time taken is nothing but what? Frequency. So Q into F, I is equal to what? So I is equal to Q into F here, where omega, so that is omega is equal to what? So 2 pi into F here, where F is equal to what? So F is equal to omega divided by 2 pi here. So let me extend this equation. I is equal to Q into F is nothing but omega divided by 2 pi here, where relation between linear velocity and angular velocity, V is equal to R omega and omega is equal to what? V by R here. Omega is equal to V by R means Q into, so wherever omega is there, so just I will fill it as V by R here. So 2 pi into R. So this is all about current here. So then already we got that about resistance. So from that Ohm's law we got mathematical expression here. So in terms of mathematical expression, so I can say that V is equal to I into R here. That resistance is depends on length and area here. So R is equal to what? Rho L by A here, where rho represents that resistivity. Resistivity also we can call it as specific resistance. So remember this word, resistivity also we can call it as specific resistance. So this resistance, however you can change the length and area, volume of the wire will be remain same. So for that purpose we got that expression. So rho into L here, so sorry, rho into L, multiply and divide by L to this equation. So rho L into L, L square divided by area into length means what? Volume I can say. Okay, then so I can rearrange further that. So density is equal to what? So density is equal to mass per unit volume, whereas volume is equal to what? So volume is equal to mass by density here. Volume is equal to mass by density. So these are all the resistance dependence factors if that a constant volume is there. So if the volume of the wire is constant, means directly proportional to square of its length and inversely proportional to its mass, we can say that. So if I consider that, so in case of that resistance, if there exists a certain kind of error, means so resistance is directly proportional to square of its length, means delta R by R. So it is equal to, square means you can take it here, 2 into delta L by L here. So one more equation, delta R by R is equal to 2 times of delta L by L. So this resistance I can rewrite in another form. So rho L by A, multiply and divided by area here. So area into length, so rho into V divided by square of the area here. So then resistance is inversely proportional to square of the area here. So instead of volume I can consider, so volume is equal to what? So density is equal to mass per unit volume, means volume is equal to what? Mass by density here. So rho into M divided by, sorry, d into a square here. So d into a square, inversely proportional to square of its area. Or in terms of radius I can consider R to the power of 4. So this is all about resistance here. Now let me look at some neat questions related to these current, Ohm's law and resistance here. Okay, so just we'll look at the questions related to current here. Number of electrons striking the screen of CRT means cathode ray tube is. So number of electrons striking the screen of CRT is, means number of electron means n value they mention. So what is its value? N is equal to 7.5 into 10 to the power of 15 or 75 into 10 to the power of 14 here in 10 second. What's the time duration here? In 10 second. So these many number of electrons will strike on the screen here. Then calculate the electric current value. So simpler thing, I value. So look at here. Here they given n means, so I can connect the formula here, n into E divided by T here. So number of electrons striking the screen will be 75 into 10 to the power of 14 here. Charge on the electrons, so 1.6 into 10 to the power of minus 19 or 16 into 10 to the power of minus 20. So divided by time taken will be 10 second here. 5 2s are 5 1s are 5 5s are. Look at here, 5 5s are here. So then 2 1s are 2 8s are 15 into 8. So that is what? So 15 into 8 means 120 here. So 120 into 10 to the power of plus 14 minus of 20. So that is minus 6 ampere here. Or current I is equal to 120 microamps. So what is the current value here? Current value is 120 microamps. So we'll look at second one. A current of 4.8 ampere is flowing in a conductor. The number of electrons passing per second through the conductor will be. So just I will read out the question once again here. A current of 4.8 amp. So I value 4.8 amp is flowing through a conductor. The number of electrons passing per second through the conductor will be. Number of electrons passing per second means, so shall I take this one as a n by t here? So which thing I need to find out here? N by t. So look at here, I is equal to n into E divided by t. So n by t is nothing but what? I divided by E here. So look at here, number of electrons per second. So I value is 4.8 or 48 into 10 to the power of minus 1. Charge on the electron, so that is 16 into 10 to the power of minus 20. So n by t value is how much? 3 into 10 to the power of minus 1 plus 20. So n by t is equal to what? 3 into 10 to the power of 19 here. Number of electrons per second will be 3 into 10 to the power of 19 here. So we'll read out the next question. Look at here. In a hydrogen atom, electron is revolving with an angular frequency of 6.28 radian per second here. Which value they mention here? Angular frequency. So that is nothing but omega here. What's that omega value? 6.28 radian per second here around the nucleus. Then equivalent electric current is in terms of 10 to the power of minus 19 amp. So which thing I need to find out here? Electric current. What is the connecting formula here? I is equal to what here? So in case of that electron, so that is Q into omega divided by 2 pi. So Q value is how much? So 1.6 into 10 to the power of minus 19 or 16 into 10 to the power of minus 20, or sorry, in terms of 19 only. Okay, so omega value is how much? 6.28. 2 into pi value means what? 3.142. So 2 into 3.142. So that is nothing but 6.28. So current value is how much? 1.6 into 10 to the power of minus 19 ampere here. So this is about current value. So we'll look at next question. The potential difference between the end of a wire of resistance 5 ohm. So potential difference between the wire having that resistance 5 ohm here. So R value is how much? 5 ohm they mention. If 720 coulombs of charges passes through it per minute, so Q by T value is how much? 720 per minute, means in terms of second. So I can consider that. So Q by T is nothing but what? Q by T is equal to 12 here. So look at here. Q by T is equal to 12. Which thing they asked to find out here? So that is nothing but V here. So from that Ohm's law, V is equal to what? I into R. Look at here. I is nothing but what? Q by T. Q by T into resistance R here. So Q by T value is how much? So 12 into 5. So what's the voltage value? 60 volt here. Okay. So we'll look at next question. Two wires of same materials having length are in the ratio 2:3. So they mention two wires. These two wires having that same material and having different length. That length are in the ratio of 2:3 are connected in series. The potential difference across the wires are 4.2 volt and 3.6 volt here. So V1 by V2 value is, so what? V1 by V2 value is 4.2 divided by 3.6 here respectively. Compare their radii. So radii means R1 by R2 value I need to find out here. So look at here, length they mention, potential they mention. I know that relation between resistance, length and radius, but here that new term they given. So look at here, first I want to find out that what is the connecting formula for that resistance and a voltage here. So from that Ohm's law, V is equal to I into R. So V is directly proportional to R here. So that I can say that R1 by R2. So that is equal to what? So resistance and V directly proportional means V1 by V2. Resistance is directly proportional to length and inversely proportional to area, A2 by A1 here. So where A2 is nothing but what? So pi into R square of 2. So pi term will getting cancelled out. R2 square divided by R1 square here. So look at here. So this term I will take out here. So I will take that R1 R2 to the right side. R1 square divided by R2 square. It is equal to L1 by L2 into V2 by V1 here. R1 square by R2 square. So that is equal to L1 by L2 means what? 2:3. V2 by V1. V2 value is how much? 3.6 or 36 into 10 to the power of minus 1. V1 is 42 into 10 to the power of minus 1. 10 to the power of minus 1 term will getting cancelled out. Okay. 4 by 7 here. So R1 square divided by R2 square. 4 by 7 here. So 4 by 7. Finally, square root means square root of 4 by 7. So square root of 4 means 2 divided by root 7 here. So this is the answer. So we'll look at next one. IV graph for a metal wire at temperature is as shown in figure here. So look at here. They given one graph here. So in that particular graph, so that graph is V versus I here. So they consider two metal here. So just I will draw on the graph. So this value is T2 and this is T1 here. So in that option they mention T1 is equal to T2 or T1 is less than that of T2 or T1 is greater than that of T2 and none of the above. So which answer is right here? So look at here. So in last class we discussed that. So in case of limitations of Ohm's law, so if you find out that slope here, so that is theta 1 you can take and this one is theta 2. So that slope is inversely proportional to resistance. So slope is inversely proportional to resistance means theta value is more. So theta 1 value is greater than that of theta 2 here. Then resistance of first wire is less than that of second wire here. Resistance and temperatures are directly proportional here, so that T1 is less than that of T2 here. So T1 is less than that of T2 means, so this option will be right here. Okay, so we'll look at next one. A copper wire of cross-sectional area 3.4 millimeter square here. So one copper wire is there, their area is 3.4 millimeter square. So millimeter means 10 to the power of minus 3, millimeter square means 10 to the power of minus 6 meter square here, and length of the wire is 400 meter. So its length is 400 meter here, and specific resistivity of copper wire is 1.7 into 10 to the power of minus 8 ohm meter. Specific resistivity is also nothing but resistivity here. So 17 into 10 to the power of minus 9 ohm meter here. Then resistance of the wire is, so which thing I need to find out here? Resistance of the wire. What is the connecting formula? R is equal to rho L by A here. So look at here, rho means what? 17 into 10 to the power of minus 9, and L means what? 4 into 10 to the power of 2 here, and area value is, so 3.4 is nothing but what? 34 into 10 to the power of minus 7 here. 34 into 10 to the power of minus 7. 17 ones are 72s, 2 ones, 2 2s. So R is equal to what? So R is equal to 2 into 10 to the power of minus 9 plus 2. So that is minus 7. Minus 7 in denominator, minus 7 term is there. So if it goes to numerator, plus 7. So R is equal to what? Resistance of the wire will be 2 ohm here. So we'll look at next one. Two different wires having specific resistivity, length, area of cross section are in the ratio of. So look at here. So they mentioned two wires here. These two wires having that specific resistivity, length and area of cross section, they given in terms of ratio here. Specific resistivity is 3:4, means rho 1 by rho 2 here. So specific resistivity means rho 1 by rho 2 is 3:4, and length is 2:9. L1 by L2 is 2:9 here, and their area of cross section is 8:27. A1 by A2 is what? 8:27 here. The ratio of the resistance of the wire is, which thing I need to find out here? Ratio of their resistance of the wire. So we are having that connecting formula as usual. R1 by R2 is equal to L1 by L2, and it is directly proportional to resistivity means rho 1 by rho 2 into inversely proportional to area, A2 by A1 here. So R1 by R2, so that is equal to L1 by L2 is nothing but what? Sorry, L1 by L2 is 2 by 9 here. Rho 1 by rho 2 is nothing but what? 3 by 4 here. A2 by A1. A2 means what? 27 divided by A1 means 8 here. 9 ones are 9 threes are here. 2 2s. So R1 by R2 is equal to 3 into 3. 9 here. 2 into 8. 16. So what is that ratio here? Ratio of the resistance is 9:16 here. So we'll look at next one. Two wires made of same materials have their length are in the ratio 1:2. So two wires are there. These two wires are made up of same materials, are having that length in the ratio of 1:2. What is that length here? Length of the two bodies means two wires are 1:2. Their mass in the ratio of 3:16 here. So they mention mass here. M1 by M2 is what? 3:16 here. The ratio of the resistance of the wire is, which thing I need to find out here? Ratio of the resistance of the wire. So resistance is directly proportional to square of the length and inversely proportional to mass for constant volume. So hope you remember this formula. So R1 by R2 is equal to what? L1 by L2 whole square into M2 by M1, inversely proportional to mass. L1 is how much? 1. So L2. So L2 means 2 here. M2 means what? 16. M1 means 3 here. 1 by 4 into 16 by 3. So resistance are in the ratio of, so resistance are in the ratio of 4:3 here. So we'll look at next one. 4 wires are made up of same materials, have different length and radii. So they mention that 4 wires, they mention these 4 wires having the same materials. All these wires are made up of same materials and all these wires having different length and radii. The wires having more resistance of the following case is, so they mention 4 wires length and radius. First one, L is equal to 100 centimeter and radius is equal to 1 millimeter, and second one, L is equal to 50 centimeter. Question will be display. So resistance, radius will be in that second option, radius will be 2 millimeter. In that third one, length is 100 centimeter and radius is half millimeter, and in that fourth option, length is 50 centimeter and R is equal to radius is equal to half millimeter. So out of these 4 wires, which wire having that greater resistance yet to be determined here. So I know the basic thing, resistance is directly proportional to length. Out of 4 wires, which wire having that greater length here? So this is 100 centimeter, this is 100 centimeter. So look at here, length is short here, so fourth and second options are not right. So out of these, first and third option, and again we'll look at that. So that resistance is inversely proportional to area here. Area means pi r square. So the wire having greater length, lesser radius, so that will give the more resistance here. Greater length, here that radius is 1 millimeter, here that length is 100 centimeter and here that radius is half millimeter. Length of these 2 wires are same here, but here radius is 1 millimeter, here radius is 0.5 millimeter. So here that less radius is there, radius of this wire is less, means then its resistance will be more. So third option is